Hello, good morning. In this lesson, let us discuss about cams. In chapter cams, discuss about how to draw a cam profile for a knife edge follower with uniform velocity and for a knife edge follower with simple harmonic motion. In this lesson, the objectives of this lesson on completion of this lesson, you will be able to draw the displacement diagrams, and also you will be able to draw the profile of the cam when the follower moves with the uniform velocity, and when the profile of the cam when the follower moves with the simple harmonic motion. First of all, let us discuss about the cam's profiles for a knife edge follower with the uniform velocity. First of all, how to draw? Once again, let us recall how to draw the displacement diagrams when the follower moving with the uniform velocity can be designed to produce the following motions for the follower: uniform velocity and also simple harmonic motion and the uniform acceleration retardation. Cam usually rotates at uniform speed so that the equal displacements takes place in equal intervals of time. The follower is required to start from rest at the beginning at each stroke and to come rest against at the end of each stroke so that its velocity must be variable. The period of cam rotation during which the follower remains at rest is known as period of dwell or dwell period. Now the displacement diagram for a follower with uniform velocity. Here is the on vertical axis, as per previous discussion. On y-axis it is displacement or the stroke or lift of the follower, and on x-axis or abscissa it is angular displacement of the follower. That means crank angles, you can say. So it is the displacement diagram and the follower moving with uniform velocity. This is the displacement diagram. It means A, B1, C1, D and E will be the displacement diagram if the follower moves with the uniform velocity for one revolution. So A to E, one revolution of the cam, and A to B, this is during outstroke of the follower, and BC, the period of dwell period at the end of stroke, and C to D during the return stroke of the follower. This is the return stroke, C to D, and the remaining D to E will be the dwell period at the end of the return stroke. So AB is the forward stroke, BC is the dwell period at the end of outstroke, and CD is the return stroke, and DE is the return stroke, dwell at the end of return stroke and before the outstroke. Let us have a small problem in this regard. That is, if the knife edge follower moving with uniform velocity. So here is the problem. The stroke of the follower is 2 centimeters, that is 20 mm, and the minimum diameter of the cam is 5 centimeters, that is 50 millimeters. The axis of the follower passes through the axis of the camshaft. That means it is simply radial follower, not offset follower. The follower moves with uniform velocity The follower motion is uniform velocity during both outstroke and return stroke. Draw the profile of cam to give the following motion to a knife edge follower. Here are the outstroke during 60 degrees of cam rotation, and well for the next 30 degrees of cam rotation, and return stroke during next 60 degrees of cam rotation, and well for the remaining 210 degrees of cam rotation. So 60 degrees of outstroke and 60 degrees of return stroke. In between these two, 30 degrees of dwell period, and remaining totally a dwell period. This is the data given to you. Here we are having number one, stroke length we are having, and minimum diameter also we are having, and type of follower is also there, and type of motion to the follower also there, and the outstroke crank cam angle, and dwell cam angle, and return stroke cam angles, and dwell for the remaining period also is given. So with this data we have to draw cam profile. Before drawing the cam profile, we have to draw the displacement diagram. Now let us see the displacement diagram. Draw a horizontal line APQ, which is equal to the 360 degrees of cam rotation, that is one revolution with suitable scale, and AS 60 degrees to represent the outstroke of the follower, and ST 30 degrees to represent the dwell period, and TP 60 degrees to represent the return stroke, and PQ 210 degrees to represent the dwell for the remaining. And draw vertical line equal to the stroke of the follower in y-axis, that is 2 centimeters, and divide the angular displacement during the outstroke and return stroke into any equal number of parts. So let it be the 6, or you can also take 4 or 8 or 10, whatever it is. Since the follower moves with uniform motion during outstroke, return stroke, therefore the displacement diagram consists of a straight lines joining AG and HP, and thus completes the displacement diagram is shown by AGHPQ. So here is the displacement diagram. So once again I will recall the field. So here is the OS is the outstroke for 60 degrees of cam rotation, and ST is the dwell for the 30 degrees of cam dwell period, and T to here is the TP will be the return stroke for the 60 degrees of return stroke, and next is PQ will be the dwell for the 210 degrees of cam rotation, right? So divide this, and y-axis, let us draw the displacement line, displacement that means lift of the stroke of the follower in y-axis for 2 centimeters, that is 20 mm, and divide this distance outstroke as well as the return stroke into same number of parts, that is even number of parts, that is here he has taken 6 parts, and here also 6 parts, and project upwards vertically, and then draw a line from 0 to G, which is representing the uniform velocity of the cam follower, and also H2P also represents the uniform velocity of the follower, and then join A, G, H and P and Q, which will represent the displacement diagram, and the vertical lines are intersecting at various points of this line. There is a point which is to be marked on the profile. A, B, C, D, E, and G. Finally, similarly, here also it is the same way. A dash, B dash, C dash, D dash, E dash, and F dash or H. So, AGHPQ line represents the displacement diagram of the follower when it moves with the uniform velocity. So now the profile, how to draw the profile. With O as center, draw a circle with a radius of 25 mm because the minimum diameter of the cam is 5 centimeters, that is 50 mm. So with center O and with radius 25 mm, draw a circle. It is base circle of the cam profile. Assume the rotation of cam is clockwise direction and mark angular displacements for lift 60 degrees and dwell 30 degrees and return stroke 60 degrees remaining period of dwell, that is 210 degrees. Outstroke 60 degrees, dwell 30 degrees, return stroke 60 degrees. Divide the angle of lift or outward stroke and angle of return stroke or angle of ascent or angle of descent into same number of equal parts as done in the displacement diagram. And obtain points A, B, C, etc. and A, B, C, A dash, B dash, C dash, etc. on radial lines such as 1A, 2B, 3C, and similarly 1A dash, 2B dash, 3C dash, etc. corresponding to the lift of the follower in respective points. So here are the displacement diagram. Here, first of all, draw the circle with the radius of 25 mm and mark from axis of the cam 60 degrees, which represents the outstroke of the follower, and next 30 degrees for dwell period, this much, and this is 60 degrees once again. This is for next. So 60 degrees of cam rotation, so that divide this as we have done in the displacement diagram, 6 parts, and here also into 6 parts, and mark from this point 1A for a same length as the displacement diagram 1A, and 1B same length as in the displacement diagram 1B. Similarly here also 3C, 4D, 5E, and 6F. Similarly here also in outstroke also same way. That means, so this is 6F dash and 5E dash and 4D dash, 3C dash and 2B dash, 1A dash. Here is 0. And join all the points, various points of this to get the required profile. So this is the knife edge follower, this is the supporting frame, and this is the base circle, and this is the outstroke, and this is the dwell, and this is the return stroke, and this is the say dwell period. And this line represents the profile of the cam, and this is the base circle, and this is the cam center, and this is the follower axis passing through the cam center. Right? In this way, you can draw the cam profile. And next is cams, and to draw the cam profile for a knife edge follower with simple harmonic motion. It's a simple harmonic motion. So here is also same procedure as we had done in the previous problem. So let us see. Cam usually rotates at uniform speed so that the equal angular displacement takes place in equal intercept of time. Follower is required to start from rest at the beginning at each stroke and to come rest again at the end of each stroke. So its velocity must be variable. And the period of cam rotation during which the follower remains at rest is known as period of dwell. Now here it is the displacement diagram. Let us see A, B, C, D, A, B dash, C dash, D dash, and A to E. So let us see, I will explain. First of all, for one revolution, AE equal to the one revolution, that is 360 degrees, which should be taken with a proper scale, that is maybe 30 degrees is equal to 1 centimeter. Then it becomes A to E becomes 12 centimeters. And divide this and also draw a perpendicular line at point A, which represents the displacement or lift of the follower or stroke of the follower with the same length, and complete the rectangle by taking lines. So after this, divide this A to E as per the outstroke, dwell, and return stroke. That means A to B will be the outstroke and B to C is the dwell period and C to D will be the return stroke and D to E will be the dwell period once again. So divide this AB into equal number of even parts, maybe 6 parts or 8 parts or 10 parts, whatever it is. Similarly, and C to D, return stroke also into same number of equal parts, and project upwards from each part in between outstroke as well as return stroke, and divide this stroke length or displacement or lift of the follower into half. Then with the half of the stroke as the radius, with the middle point of the stroke as the center, draw a semicircle and divide this semicircle into same number of equal parts, even number of parts as done in the outstroke as well as return stroke. That means if you have done 8 parts here in this and here in this, the same number of parts has to be done. That is here also 8 parts or 6 parts, whatever it is. And mark all these parts and draw the projectors, horizontal projectors from each point of the semicircle to intersect the vertical parts of outstroke and return stroke. So say suppose this is the 1 point, 2, 3, 4, 5, 6, 7 and B are 8, and it is 1, 2, 3, 4, 5, 6, 7 and 8. So then if you draw, if there is a vertical line or projector from 1.1, and similarly here is the horizontal projector, if you draw here in this like this, then the vertical projector as well as horizontal projector will intersect at certain point, that is called point 1, P1. And similarly vertical projector of second point and horizontal projector of semicircle will intersect at one point, that is point 2. Similarly, third point, vertical projector and semicircle horizontal projector will meet at one point, intersect at one point, that is point 3. Similarly, point 4 and point 5, point 6 and point 7, and finally point 8. After marking this, once again go to this outstroke also. So this is a 1, 2, 3, 4, 5, 6, 7, 8, or and this horizontal projector 1 will intersect 1 dash vertical projector at point here P1 dash, and this will become P2 dash, P3 dash, P4 dash, and P5 dash, P6 dash, P7 dash, and C1 or P8 dash. Like this, you can compare and join all these points A, P1, P2, P3, P4, P5, P6, P7, P8 or B1, and then C1, and join P8 or C1, P7 dash, P6 dash, P5 dash, P4 dash, P3 dash, P2 dash, P1 dash, and finally D. And complete this line. So then A, B1, C1, D, and E will be the displacement diagram if the follower moves with simple harmonic motion. So the displacement diagram for simple harmonic motion of a follower is A, B dash, B1, C1, D, and E as shown in the above figure. Procedure, let us see once again. First, draw a semicircle on the follower stroke as shown in figure. And then divide the semicircle into any convenient even number of equal parts. Let us say 1, 2, 3, 4, 5, 6, 7, 8. Divide the angular displacement of the cam during outstroke and return strokes of the same number, that means of the follower, into the same number of equal parts. The points on the displacement diagram are obtained by projecting the points as shown in figure. Obtain the intersecting points A, but previously I explained P1, P2, but here it is A, B, C, D, E, F, G, H, etc. And similarly A dash, B dash, C dash, D dash, E dash, F dash, etc. Then complete the curve by joining A, B1, C1, D1, E. So let us see the procedure here in this case once again. It is the problem. Draw the profile of a cam operating a knife edge follower. Here is the knife edge follower. When the axis of the follower passes through the axis of the crankshaft, it is radial cam, not offset follower. Now the given data is follower to move outwards, that means outstroke through 40 mm, that means raise off or lift or stroke of the follower is 40 mm during 60 degrees of cam rotation, and the follower to dwell for the next 45 degrees of cam rotation, and the follower to return stroke to its original position during next 90 degrees of cam rotation. The follower to dwell for the rest of the cam rotation, that means 60, 45 and 90, and remaining period is the dwell period. The displacement of the follower is to take place with simple harmonic motion. That means here the motion of the follower is simple harmonic motion during both outward and return stroke. The least radius of cam is 50 mm. That means base circle radius is the 50 mm. This is the data given for us. With this data, that means here in this case, offset knife edge follower, outstroke 60 degrees, dwell 45 degrees, and return stroke 90 degrees, remaining dwell, and also lift or stroke is 40 mm, and least motion is the simple harmonic motion, and least radius of the cam is 50 mm, that means base circle radius. So lift of the follower S is equal to 40 mm and outstroke 60 degrees, and the angle of dwell for the outstroke 45 degrees, and angle of return stroke 90 degrees, and the angle of dwell for return stroke is 165 remaining angle. So total this is 165 degrees for the next second return stroke, and the least radius of cam is 50 mm, and the speed of the cam is 300 revolutions per minute. Angular velocity of cam is so this much, 31.42 radians per second. Now let us have the displacement diagram. Let horizontal scale is 10 mm is equal to 30 degrees. So vertical scale 10 mm is equal to 10 mm only, and draw horizontal line AB equal to 360 degrees. That is on this line take AC 60 degrees to represent the outstroke, and CD 45 degrees to represent the dwell after stroke, and DE 90 degrees to represent return stroke, and EF to represent the dwell for the return stroke. Here is the diagram. So same as in the previous explained displacement diagram, A to here, this B maybe is the cam rotation, which is equal to 360 degrees for one revolution. That means 130 degrees is equal to 10 mm, that means 120 mm total length. And 60 degrees here is 20 mm AC outstroke for 60 degrees, and 45 degrees it is 1 point some 5 degrees I see, 15 mm, and this is 90 means 330 mm, and this is the outstroke and dwell, and this is the return stroke, and remaining part is dwell period. So once again divide this line into 6 number of parts, and here also divide this out return stroke also into 6 divisions, and draw from each point vertical projectors like this. And similarly here also 6 dash vertical line, here also 5 dash 4 dash vertical line, and similarly he draw the vertical projectors, and at point A or 0 draw a vertical line equal to the lift of the cam or follower, or lift of the stroke of the follower, that is 40 mm at this problem, and divide with the center of this lift middle point with say half of the lift as the radius, that is 20 mm as the radius. Draw a semicircle and divide this semicircle also into same number of parts as 6. So same divisions 1 2 3 4 5 6, and from each vertical semicircle points draw horizontal projectors to intersect the vertical projectors at outstroke and return stroke. So 1 and 1 will meet at point A, 2 and horizontal projector 2 will meet at intersect at point B, and similarly 3 and 3 vertical projector intersect at C, and similarly 4 horizontal and 4 vertical will meet at D. Similarly 5 horizontal and 5 vertical will meet at point E. Similarly 6 and 6 at point F. And here also, so let us see from in this direction, reverse direction, 1 dash and 1 will intersect at A1, and 2 dash vertical projector and 2 horizontal projector will intersect at B1 B dash, and 3 dash vertical and 3 horizontal will intersect at point C1. Similarly D1 E1 etc. So with this we can complete. So after joining A, capital A or 0, A, B, C, D, E, F and F dash, E dash, D dash, C dash, B dash, A dash and E, and finally P to the B. We can complete the displacement diagram when the follower moves with the given data, that is simple harmonic motion, and 60 degrees outstroke, dwell 45 degrees, 90 degrees return stroke, and remaining dwell period. So after completion of this, let us go to the profile. So from A, draw vertical line AF equal to 40 mm to represent the lift of the follower. Complete the rectangle AF GB, which is draw a semicircle with AF as diameter. Divide the semicircle into any equal number of even parts. Join them with center of each semicircle. Through each division points 1, 2 up to 6, draw horizontal lines as shown in figure, and divide the distances AC, DE into 6 equal parts marked as 1, 2, 3, 4, 5, 6 for outstroke, and 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash for return stroke. And draw vertical lines through these points as shown in figure, and these vertical lines intersect the horizontal lines at A, B, C, D, E, F for outstroke, and A dash, B dash, C dash, D dash, E dash, F dash for return stroke. So joining the points A, B, C, D, F, and F dash, D, E dash, T dash, C dash, V dash, A dash, O dash, and B by a smooth curve shown in figure. This curve shows that this will be the displacement diagram, not the cam profile. So now here it is the displacement, cam profile of the given data with the given data, that is cam profile for a knife edge follower moving with the uniform velocity, simple harmonic motion. So first of all, draw the circle with the radius 50 mm with center O, which is the base circle, or also called this as the base circle or prime circle of the cam. And mark at any point on the circle one point. From this point, draw a knife edge follower, and the axis of the follower should pass through the axis of the base circle or the prime circle, and with the point center O, and from OA line mark angle of outstroke, dwell, and return stroke, and remaining dwell period. It means from OA mark 60 degrees, which represents the outstroke of the follower, and next 40 degrees, which represents, that means A to C 60 degrees, and C to D represents the dwell period, and D to E 90 degrees, which is equal to return stroke of the follower. Next, and divide this AC into same number of equal parts as done in the displacement diagram. And similarly, divide this D to E also into same number of divisions as done in the displacement diagram. That is, here also 0 or A, 1, 2, 3, 4, 5, 6. And project each line, each division, draw O1 and extend it, O2 extend it, O3 extend it, and O4 extend. Similarly, O5 extension, O6 extension, etc. Similarly, here also O6 dash extension, O5 dash extension. Similarly, here also. After drawing lines from each point on the circle through the point O, then take the lengths from displacement diagram 1A, as in the displacement diagram using compass, 1A point, mark A, and similar to B, and 3C, 4D, 5E, and 6F similarly, and here 6 dash, F dash, 5 dash, E dash, 4 dash, D dash, 3 dash, C dash, 2 dash, B dash, 1 dash, A dash similarly. After marking points A, B, C, D by using displacement diagram lengths, and join with a smooth curve by freehand, capital A, B, C, D with a smooth curve, even including dwell period, and join F dash, E dash, D dash, C dash, etc. up to E, and also complete this circle up to point A, and which will show the cam profile for the given data. So here you can see this is the knife edge follower, and this is the axis of the follower, and this is the axis of the cam, perpendicular axis or perpendicular to this axis of the cam follower, and this is the prime circle or also called base circle, and this is the outstroke, and this is the return stroke, and this is the cam profile. So with this we can complete this cam profile. Draw a prime circle with O as center and a radius equal to 50 mm. That is minimum radius of cam. Also this prime circle in this case also called base circle. And mark angles of 60 degrees to represent the outstroke, 45 degrees to represent the 90 degrees of the prime circle to represent the outstroke, return stroke, and 12 return stroke, etc. respectively, such that the angle AOC is 60 degrees, angle COD 45 degrees, angle DOE 90 degrees. Divide the angles AOC, DOE into the same number of even parts. From O, you draw radial lines O1, O2, O3, O4, and O6 up to O6 for outstroke. Similarly, O6 dash, O5 dash, and similarly up to O1 dash for return stroke. Produce these radial lines as shown in figure. And from O, draw radial lines O1, O2, O3, and similarly here also for return stroke also. The same as in the outstroke. And now mark points 1A, 2B, 3C, and similarly 4D, etc. 6F, and similarly 6 dash F dash, 5 dash E dash, etc. up to 1A, 1 dash A dash equal to the corresponding displacements as measured from the displacement diagram. A smooth curve passing through points A, small a, B, C, D, F in figure shows the profile of the cam during the outstroke. The curve F dash, E dash, D dash, C dash, B dash, E dash, and A dash, and E shows the profile of the cam during return stroke. For the dwell period, so O as center and radius equal to OF, draw an arc F dash. The arc of the circle will be parallel to prime circle. And EA, the follower, is rest for the remaining of the revolution. The complete the profile as shown by a thick or dark lines. So like this you can complete. So far in this we complete the profile for the given data. So let us have the summary of this lesson. The follower moves with uniform velocity during its rise and return stroke. Therefore, the slope of the displacement curve is constant. The slope of the displacement curve is, in this case, is constant. To draw the cam profile for the follower must rotate opposite direction to the cam rotation. And to draw cam profile, the velocity of the follower is 0 at the beginning and at the end of its strokes. When the follower is moving with simple harmonic motion. When the follower is moving with simple harmonic motion, at the beginning, at the end of each stroke will be 0. The velocity will be 0. Velocity gradually increases to the maximum at its mid stroke. So let us have, this is a small summary of this lesson. Now let us have a quiz on this. The angle between the direction of the follower motion and a normal to a pitch. Direction of the follower and a normal to the pitch is called angle of well. This quiz is there in our previous lessons, that is nomenclature of the cams, angle of dwell, angle of ascent, pressure angle, and angle of descent. So simply the C should be the answer in this case, pressure angle, because direction of the follower and normal of the pitch curve will give you the pressure angle, right? C will be the answer. The smallest circle that can be drawn to the cam profile is known as addendum circle, prime circle, pitch circle, base circle. The smallest circle that can be drawn to the cam profile is known as, let us see, addendum circle, prime circle, pitch circle, base circle. So base circle will be the right answer. In case of knife edge follower and flat follower, base circle itself is nothing but the prime circle. Whereas in case of roller follower, base circle is the smaller circle and next smaller circle is the prime circle. Right? So in this quiz question, so D will be the right answer. The displacement diagram is dash during its rise and return stroke. When the follower moves with uniform velocity, cycloid, straight line, parabolic, none of the above. The displacement diagram is a straight line, right? So B should be the right answer. The angle lost bit is the angle moved by the cam during which the follower remains at its highest position is called. The angle moved by the cam during which the follower remains at its highest position is called angular dwell, angle of ascent, angle of descent, pressure angle. Which is the right answer? So highest position is angle of dwell, which is at rest. So let us have small assignment questions, two assignment questions for knife edge follower with uniform velocity and also knife edge follower with simple harmonic motion. Construct a cam profile using the following data: outstroke during 90 degrees of cam rotation and dwell for the 30 degrees of cam rotation, return stroke for the next 90 degrees of cam rotation, and dwell for the rest of the motion. This 90 plus 90, 180 plus 210. So remaining is the dwell period, and stroke of the follower is 25 mm. Minimum radius of cam is 50 mm, and the axis of the knife edge follower is in line with the axis of the camshaft, that is radial follower, not offset follower. So knife edge follower, that means knife edge follower passing through the cam center. Axis of the knife edge follower passing through the cam axis. The follower moves with the uniform velocity, outstroke and return, both in outstroke and return stroke. This is a simple problem as we had done. Right? You can solve this problem very easily. And next problem assignment is construct a cam profile using the following data: outstroke during 120 degrees of rotation, dwell for 60 degrees, next 60 degrees of rotation, return stroke for next 90 degrees of cam rotation, dwell for the next of motion, and stroke of the follower 30 mm, minimum radius of cam 50 mm. The follower moves with uniform velocity during both the outstroke and return stroke. So this also same problem, same as the previous class, only angles have been changed. The stroke changed and this values are changed, but procedure will be the same as solved first problem. Next assignment, draw the profile of cam operating knife edge follower with simple harmonic motion. Here is the simple harmonic motion, whose outstroke is maximum displacement 180 mm. That means stroke of the follower is, or lift of the follower is 180 mm during 180 degrees of cam rotation. Return stroke for the next 150 degrees of cam rotation and dwell during remaining 30 degrees of cam rotation. Here only one dwell period is there, 180 degrees plus 150 degrees plus 30 degrees, total 360 degrees completed, but that's why there is no dwell in between outstroke and return stroke. There is only the difference in this problem. The axis of the follower passes through the camshaft axis. Minimum radius of the cam is 150 mm. So this problem is also same as the second problem, but only in this difference is there is no dwell period in between outstroke and return stroke. That is only the difference. That's all. And draw the profile of cam operating a knife edge follower when the axis of the follower passes through the axis of the cam shaft. Follower to move outwards. Here is the knife edge follower, and outwards through 40 mm, that is stroke 40 mm during 90 degrees of cam rotation with simple harmonic motion. And the follower to dwell for the next 30 degrees, and follow to return stroke for its original position during 60 degrees of cam rotation. Here is has not mentioned any simple harmonic motion or whatever it is, but we have to assume that it is a simple harmonic motion. So for the 30 degrees of cam rotation, and follow to dwell for the rest of the cam rotation. The least radius of the cam is 40 mm. Right? This is also a simple problem as second problem. So thank you. So for in this lesson we have completed knife edge follower, moving with uniform velocity. For that, displacement diagram as well as cam profile we have discussed. And the second one is knife edge follower with a simple harmonic motion. Also we have completed a small quiz also there, and 4 assignment problems are also there. If you solve 4 assignment problems, you can have thorough knowledge about this problem, right?